Today we're starting Chapter 2, so we are on page 1 of our Chapter 2 notes packet. Section 2.2, Simplifying Rational Expressions. A rational expression is the quotient of two polynomials, and we have 4 examples listed. M squared n divided by 3m n to the third, the trinomial x squared plus x minus 12 divided by x squared plus 10x plus 24, 5 over y, negative 2 over 7. These are all rational expressions. Recall that in a rational number, a over b, a and b are integers. b cannot equal 0. Remember, the denominator of a fraction cannot be 0. In a rational expression, a over b, a and b are polynomials. This is going to be our focus for Chapter 2. We'll be working with rational expressions for the most part. Recall, division by 0 is not possible. A rational expression whose denominator is 0 is meaningless or undefined. So we have 4 exercises here. For what value or values of x is each expression not defined? We'll take number 1. We have 5 over x minus 3. Again, just focus on the denominator. This expression would be undefined when the denominator x minus 3 equals 0. Well, for what value of x would result in 0 if we replaced x with 3? When x equals 3. Look at our next expression. Again, just focus on the denominator. We have a denominator of x squared minus 16. Well, you can think, well, what squared subtract 16 would result in 0? Well, 16 subtract 16 would give us 0. So 4 squared minus 16 would result in 0. Or you might recognize this as being the difference of two perfect squares. And if you factor this into x plus 4 times x minus 4, you know that if you replace this x with negative 4, that would result in 0. Or if you replace this x with positive 4, then 4 minus 4 would result in 0. Look at number 3. Again, the denominator, 2x minus 1. Well, when is 2x minus 1 equal to 0? For what value of x? Well, you could actually take the equation and solve it. Add 1 to both sides. I'm not showing that step. Divide by 2. So when x is a half, so think about that. 2 times a half would result in 1, and 1 subtract 1 is 0. And now for the last one, well, again, think of factoring. There's a GCF here of x. If I factor out x, I have x times x minus 4. Well, when does this equal 0? Well, when the one factor is 0, or when the other factor is 0. So, this rational expression here would be undefined if x is 0, or if x is 4. Right? 4 squared is 16, subtract 4 times 4 is 16, result is 0. Now, reducing to lowest terms. A rational expression is reduced to lowest terms, or stated in simplest form, when its numerator and denominator have no common factors other than 1 or negative 1. This is important here. To reduce a rational expression, you factor both numerator and denominator. Okay, you are going to factor both numerator and denominator. Then, once the numerator and denominator are factored, you may divide out common factors. And dividing out the common factors, you're also familiar with the term known as canceling. Okay, so you factor both numerator and denominator first. So first thing you always do is factor. All right, so we want to simplify this rational expression, 2x minus 6y divided by 4x minus 12y. Factor the numerator. There's a GCF. 2. Factor out the GCF of 2, and the other factor is x minus 3y. Go to the denominator. Factor out the GCF of 4. And our other factor is x minus 3y. So now both numerator and denominator are factored. Now we can divide out the common factor of x minus 3y, and the 2 and the 4 we may reduce. 2 into 2 once and 2 into 4 twice. So our end result is 1/2. So this rational expression reduces to 1/2. Now, when you show that you're dividing out common factors, you just do as I did and put a slash through the common factor. You don't want to scribble it out. I have to be able to see the factor underneath. Okay, the next one, number 2. Factor the numerator, factor the denominator. There's a GCF of 4x. So we factor out 4x, and our other factor is x plus 2. And our denominator, let's see what's common here, is a 6x squared. And our other factor is x plus 2. The x plus 2's are common to both numerator and denominator. They divide out or cancel out. X and x squared will leave us with a single x in the denominator, and the 4 and the 6 reduce. 4 divided by 2 is 2, and 6 divided by 2 is 3. So, simplified, we have 2 over 3x. 2 divided by 3x. Next, number 3. Factor the numerator. Difference of two perfect squares. X plus 5 times x minus 5. Factor the denominator. GCF, 3, x minus 5. What's common to both numerator and denominator? The x minus 5's. They divide out. Nothing else reduces. So our result is x plus 5 divided by 3. Number 4, we have two trinomials. Never, these are terms. X squared is a term, 4x, 3 is a term. Those are 3 terms of the numerator. Denominator has 3 terms. You never cancel out terms, okay? Rather, we factor this trinomial. The factors of 3 that add to 4 are 3 and 1. So x plus 3 times x plus 1. And for the denominator, the factors of 1 that add to 2 are 1 and 1. So x plus 1 times x plus 1. The x plus 1's are common. They divide out. X plus 3 is a binomial that is totally different than the binomial x plus 1. Next, page 2, number 5. Again, just continuing factoring numerators and denominators and dividing out common factors. The trinomial factors of 16 that add to 8 are 4 and 4. X plus 4 times x plus 4. And our denominator, difference of two perfect squares, x plus 4 times x minus 4. And the x minus 4's, one from the numerator divides out with the one from the denominator, and the others stay. So their end result is x plus 4 divided by x minus 4. Again, these are two different binomials. Number 6, looking for GCFs here. X squared, y, x plus y, our other factor. X squared, y again, and then x minus y. The x squared y's divide out. So we're left with x plus y divided by x minus y. Next, number 7, GCF of 3, take out 3. You get x squared minus 16 in parentheses. Notice that you can factor this further, all right? So that's going to factor into x plus 4 times x minus 4. The trinomial of the denominator, the factors of -8 that add to -2, -4, and 2. So x minus 4 times x plus 2. We just move this over to here so that I'm lined up. Excuse me, this is supposed to be a minus. Now what's common? The x minus 4s. They divide out, and that's all that divides out. So our numerator is 3 times x plus 4, and a denominator of x plus 2. You can distribute the 3, but it's not necessary, so I'm not going to do any more work than that is necessary. So we'll leave it as 3 times x plus 4 divided by x plus 2. And next, number 8, we have this trinomial. The lead coefficient is not 1, it's 2, so we have to do our longer process of factoring in and factoring out. So 2 times -5 is -10. The factors of -10 that add to -9 are -10 and 1. So remember, this is a side step here. The lead coefficient 2 goes in the denominator and leads off both binomials in the numerator, 2x minus 10 and 2x plus 1. 2 divides evenly into 2x minus 10. It goes in x minus 5 times. So x minus 5 times 2x plus 1 are the factors of our numerator. Our denominator, recognize this as a difference of 2 perfect squares. 2x plus 1 times 2x minus 1. And our 2x plus 1s are common to numerator and denominator. They divide out or cancel out. So our simplified expression is x minus 5 divided by 2x minus 1. Next, factoring out a -1. So we're still simplifying. Factoring out a -1. If we look at number 9 here, x minus 3 divided by 3 minus x, I call these opposites, right? Opposites. -7 divided by +7 would result in -1. Take any number for x here. 5. If I put 5 in for x, 5 minus 3 divided by 3 minus 5. Well, what is 5 minus 3? It's 2, and 3 minus 5 is -2. 2 divided by -2 is -1. And this only works if it's subtraction. You have x minus 3, and then for the denominator, 3 minus x, where you can think of the denominator as -x plus 3. In the numerator, positive x, denominator negative x. In our numerator, -3, denominator positive 3. These are opposites, so what's going to happen is their result, they're going to divide out and they're going to equal negative 1. Let's look at this in some other problems. Okay, in number 10 we have y minus x divided by 2 times x minus y. My numerator, positive y, negative x. Denominator has a factor of negative y, positive x. These are opposites. So you divide out and you put a negative 1. Replace one of the factors with negative 1. It doesn't matter whether it's the factor of the numerator or the denominator. So this equals to negative 1/2. Next, number 11, we have 2 plus x divided by x squared minus 4. Again, we're still looking to simplify this. There's nothing to do as far as factoring goes for the numerator, but for the denominator, this is the difference of two perfect squares, x plus 2 times x minus 2. Now, don't get tricked. X plus 2 is the same as, and I read it backwards, 2 plus x is the same as x plus 2. The order is just different, but these are still the same two factors. So these divide out as they are, right? Positive x, positive 2, positive 2, positive x. And we're left with 1 over x minus 2. Number 12, we've got a factor here. The numerator, let's see, what's in common? An xy, and then 2y minus 3x is our other factor. Denominator, 2x is the GCF, and 3x minus 2y. Looking inside our parentheses at our two binomials, 2y minus 3x in the numerator, 3x minus 2y in the denominator. These are opposites. Positive 2y, negative 3x, negative 2y, positive 3x. They're opposites, they divide out. So cancel out, replace with a negative 1, and the x's divide out. So our answer is negative y over 2. Right, that's all we have left. Y times negative 1 is negative y over 2. Number 13, and certainly by all means, if you want, you can always pause the video and try and go ahead. All right, so if you want, try number 13 on your own. Factoring 1 plus 3x, difference of two perfect squares, 1 minus 3x. GCF, x, 3x minus 1. These are opposites. They divide out. I'll put the negative 1 in the denominator. So our numerator is 1 plus 3x, and our denominator is now x times negative 1, or negative x. Again, the negative could have been placed up in the numerator. If it is, make sure you have parentheses around the binomial, or you can also place the negative out in front of the fraction. Okay, and our last one, number 14, nothing to factor in the numerator. That just stays as is. Our denominator, this is a factor in, factor out, negative 28. The factors of negative 28 that add to positive 3 are 14 and 2. No, 7 and 4 rather. Positive 7, negative 4. Fraction bar, 2 in the denominator, 2x plus 7, 2x minus 4, and 2 goes into the 2x minus 4, x minus 2 times. And bring over our other factor, and then recognize the 2 minus x and the x minus 2 are opposites. I'll place the negative 1 in the numerator, Result, negative 1 over 2x plus 2. And this completes our lesson for today.